Hey, welcome to an introduction to Ggplot for Bioinformatics. This is part one of a multi-part series. The main purpose of this is to introduce you to tidyverse tools like Ggplot2 and dplyr, and especially in the subsequent parts focus on biological data like RNA sequencing data. There's already a lot of resources online for the tidyverse tools. My favorite is the R for Data Science book, which you can find for free online. But that book is pretty dense, it has a lot of material, and the purpose of this video is just to get you up and running with these tools as fast as possible, and a lot of the theory and logistics and more details can come with time. So the main audience for this are people who've used R before, so you know what RStudio is, you can maybe pull up and load some data, but you haven't used Ggplot before, nor tidyverse or anything with this grammar of graphics idea. Our goals for this: we're going to download some data online. We're going to load and preview that data, which will be in a tab separated file. Then we're going to create a scatter plot of a couple of variables in that data. And in that, we're going to see kind of the structure of a Ggplot plot, which we would call this grammar of graphics, which is just you load things in a certain order and you kind of build your graph layer by layer. Then we'll create a histogram as well, and then we'll go over some of the features of Ggplot that might make it useful, and it's part of the reason why Ggplot is the most used graphics package for R. And I think when you go out to professional settings or to industry, this is really what most people use. And then after the video, I really would encourage you to follow along with the exercises in this video, and then I'm going to give you another data set so you can go practice everything that you've learned on your own. Let's get started. Go ahead and open up RStudio. Instead of, let me erase this. So instead of RStudio on my computer, I'm going to use RStudio in this cloud platform. You can use it as well if you want at rstudio.cloud, just to make sure I don't have anything else that's messing with our analysis here. But you can use your own version on your computer. And then in the description of this video, you should find a link to the penguins.txt file. So you can go ahead and open that link and download that file somewhere to your computer. I already downloaded it to this instance of RStudio, and I put it in this My Data folder. So if you're following along on your computer, you might want to pause, download the data, and then in RStudio, navigate to where that data is, and then we can click on the gear to set this as our working directory. So first things first, there's some packages that we're going to be using throughout this session. Those are, I'll put them up here. So this was, I opened up a script here by going File, RScript, and that's just what this is. And you can go ahead and install Ggplot2 and tidyverse. I already installed them here, so I won't run them. And the first thing we're going to do is load the penguins dataset. And we can do that with base R, which you might be familiar with. So for that, we would do penguins equals read table, and here's our penguins.txt. And this is separated by a tab character. So now if we look at penguins, we'll get this long output with all of the columns, which to me is a little hard to read. I prefer loading with tidyverse. So this up here is with base R. And the tidyverse version, of course, we have to load the tidyverse library first. And it looks very similar. Instead of read table, we'll use read delim. It's still file name first, and instead of separator, we use delim, which is the same thing, just whatever's separating the columns in the file. We'll notice the moment we run this command, we get some output saying that the file was read. It tells us how many rows there were and how many columns, and also the type of each row. So for example, species is a text, like a character vector, whereas body mass is a double. And this data set just contains a bunch of measurements of penguins from the Palmer Scientific Station in Antarctica. And so now if we actually run penguins and look at what it is now, instead of being a normal data table, it's a tibble, which is kind of a tibble, which is the tidyverse version of a data table. And it also specifies the type of each column. So for example, body mass here is a double, a numeric vector, and it gives us just a few values so that we have an idea of what the data set looks like. Now that we've loaded our data, we can create a scatter plot. And let's say, let's do a scatter of maybe of body mass versus bill length. So you might imagine maybe bigger penguins, more massive penguins, have longer bills, or vice versa. And maybe we can see that relationship if we make a scatter plot. We can do that with base R, and you may already be familiar with that. That we would use the plot command, and we could get the bill length. Oh, that's depth. So bill length on one hand, and body mass. And we could even specify that this is going to be our X, and this is going to be our Y. And we get a scatter plot. And I'm going to show you how to make a very similar scatter plot with Ggplot. And that follows this kind of pattern of loading the data first, then specifying a mapping. So we're going to load our penguins data. We're going to specify which columns in the data go to the x-axis and which column goes to the y-axis. And then we're going to add some geometric representation. So that'll be, we'll specify to make points to make a scatter plot. So first we're going to load our library, which is Ggplot2. Ggplot2. And the first thing we'll do is load our data. So we're going to use the ggplot command without the 2 and specify that our data is penguins. And then we also have to specify a mapping. So mapping equals, and we use this command AES because it stands for an aesthetic mapping. And we see here our help describes what our aesthetic mapping does is link our variables in our data to visual properties like the axes. And we're going to have an X and a Y. Our X, just like before, is going to be bill length millimeter. Notice I don't need any quotation marks, and I don't have to specify what data set it's coming from because I already have my data here. And our Y is body mass G. So if we go ahead and run this command, we won't get a scatter plot, but it will set up our axes for us and figure out what numbers should be on those axes as well. To make a scatter plot, we use this plus symbol, which you may only see in Ggplot, and this adds additional layers to the plot. So you can imagine we set down this layer of the axis, and now we want to put dots on top of that layer. And we can use geom points or geom point to make those dots. So here's our scatter plot. And that's the basic idea. This is how you make plots in Ggplot. You might ask, okay, we've made a scatter plot. What about other plots? So what about create a histogram? Maybe we make a histogram of body mass. We have the same idea, right? So Ggplot, data penguins. Think about what mapping we might need. So mapping always starts with AES. And we only have one variable, body mass. And we can just call it X. So X equals body mass G. Now we're going to do a plus just like before. And the geometric representation for a histogram is geom histogram. Run that and we get a histogram. All right, so we can now make a scatter plot and a histogram in Ggplot. There's a few things that make Ggplot nice. One of them is this idea of adding layers after layer. Another one is that you can assign plots to a variable. So for example, we have this scatter plot up here on line 25. Let's run it to remind us. And we can assign it to a variable. So let's call it, what did I want to call it? Maybe just, this is the length versus mass scatter, maybe. And we can assign it just like any other variable. And let's say now, we made that plot a while ago, and we want to add some layers to our scatter plot. So I can go ahead and just run that variable versus mass scatter, and that plot should appear. It was already there, but we can now add more layers to it. So maybe I want to change the axis. I can do a plus, or like the labels for the axis rather, right? So the X label, maybe instead of this underscore thing, we can say bill length in millimeters. And we'll see we just changed that X-axis. And now we can change the Y-axis in the same way, body mass, and that's in grams. We change that axis. And there's a lot of these different layers you can put on. For example, we could add a title. So here's ggtitle is the command for that. Maybe we see a correlation here. It looks like maybe we want to say that penguin bill length looks like it correlates with body mass. So now we've added a title, which we'd have to zoom to see the title properly. So we can just keep adding things on like this, and we can save it as a variable, and it makes it easier to reuse these plots later. Another common layer are themes. So I usually like to use the black and white theme, so theme BW, and that just changes the background to clear on here and does a few other things. So that's how we add layers to Ggplot. There's also this idea of piping. So let's say I'm going to take our original code, say for the histogram. So here's our histogram code. And I can run it and get a histogram. There's another thing that I can do is I can take this penguin's data, and rather than specifying it here, I'm actually going to delete that. And we can take the penguin's data and actually pipe it into the command. So this is a base R pipe, this little symbol here. And you can imagine it almost like a drain pipe. It takes the penguin's data and it flushes it into the ggplot command. We'll see if we run this command, the same thing actually happens. So that's a pipe, and actually this is the new pipe. This only was released, I think, less than a year ago now. So you'll see a lot of times, this is we would call it now the base R pipe, because it's built into R. There's also the old pipe, or I'll call it old pipe, and that comes from this library called Magretter, M-A-G, and that's actually from this piece of the This Is Not a Pipe painting, which you can look up if you're not familiar with, which people thought was clever, because all that this library does is it gives you a pipe. And that pipe you might see in some places because it looks like this. So if you see that symbol, that's what that is. And it has basically the exact same function. It can pipe that data into the graph in this case. And you might ask, how does this help us? If we could just put it inside the ggplot command. One thing that it can, so like applications of the pipe, one thing it helps with is if you're manipulating the data. So let's say I have the penguins data set, and maybe I want a histogram just for all of the male penguins. So I can take the penguins data set, and I'll use the old pipe to pipe it into the filter command. And I can use the filter command to say we only want male penguins. If we run that, we'll now see the penguins data set, but only with male penguins. And then I can pipe again. And I'll pipe to ggplot and do everything else the same. X equals body mass grams, and then geom histogram. And now I have a histogram of just the male penguins. So watch this. Maybe we can change it to female and run, and the histogram will shift slightly. All right. So that's a way to manipulate the data and then pipe it into plotting. So that's the pipe. We can also talk some about facets that are really useful. So let's say instead of changing this command between male and female penguins, I wanted to do it all at once. Well, I can take my old ggplot command here, let's take penguins, so facets. Let's take penguins and pipe it into Ggplot, and our same mapping as before, is body mass grams, and we're making a histogram. Now we can add this, this command called Facet Grid. And for Facet Grid, I can specify, well, what I'm going to do with this command is make multiple graphs, one for males, one for females, and one for the rows that aren't filled out with a sex. And since we want to display those multiple graphs across rows, I can use the rows command. And I'm going to set that equal to all of the variables inside the sex column. So this vars command is always required. If we run this, we now get all three of those graphs for free. And we can kind of see how the female penguins on average have less mass than the male penguins, even though there's some overlap. You see these female penguins are actually more massive than all of these male penguins. And the ones that weren't assigned a sex fall along both of those distributions. Maybe we could guess that this unassigned one is more likely to be female. Or this unassigned one's maybe slightly more likely to be male from these distributions. So that's how facets work. And those can be really useful when we're plotting lots of data. Maybe we have many variables and we want to take a look at the distributions all at once. So that's basically it. Remember, the basics of this is that whenever we're, for example, making a scatter plot, we're going to always, or anytime we're making any sort of Ggplot, we're going to start with the data, then we're going to add the mapping, and then we'll add whatever geometric representation we want on top of that mapping. And in the description, I'm going to provide a link to the mtcars dataset. So for practice, plot some variables, so plot variables from mtcars. You can access this dataset directly in R by typing data mtcars. And then if you just run, it makes a variable called mtcars that you can call. And then here's this dataset. And you can ask questions about, if you want more description of the dataset, you can use this question mark. And here we see that this is a data set that comes from a bunch of cars from the 70s about their fuel efficiency and weight and the like. And just so that you can practice loading data, I threw this data set onto Google Drive if you want to download it and load it. And go ahead and take a look at some of these relationships. See if, for example, there might be a relationship between fuel efficiency in this MPG column and weight of the car or something like that. Maybe you make a plot of that. Or maybe you can make a histogram of mile per gallons with across different cylinders, things like that. Take a look at that data set, play with it, and let me know if you have any questions. I hope that was helpful. See you in the next one.